Okay, good morning, everyone. Welcome to Marinay's Powerhouse Team Review and Training Center. So my name is Engineer Reggie Marinay. We'll be discussing about the Maxwell's mesh method. So this is actually part 7 of the topic of the subject, direct current circuits. So I will discuss first the principle of the Maxwell's mesh method. Okay, I have here on the board, we have two sources. So E sub 1, then we have here our E sub 2. Then we have R1, R2, and R3, R4, and R5 resistors. So basically, we have three loop circuit here. Three loop circuit. Actually, the Maxwell's mesh method is based on Kirchhoff's voltage law and Kirchhoff's current law also. Okay? So, let's say we have here our I1, I2, I3. Then we have our I4. Then we have our I5. Then sub 1. Our I sub 1. Then we have I sub 2 here. Okay. So, of course, we will not solve this uh, all the branch current. We will not solve I4, I5. So, it's very hard to form a 5 equation, 5 unknowns. No? We will reduce this into 3 equation only. But how to do it? So, please take note that our I sub 4, let's say at this node, let's say we have our node 1 by Kirchhoff current law at node 1. Okay, so at node 1, Kirchhoff current law states that all the current entering, so we have here our I sub 1, that is equal to the current leaving. So we have I2 that is equal to I2 plus I sub 4. I sub 4. Okay? So how to get our I sub 4? So our I sub 4, that will be equal to, let us transpose I sub 2, so that is equal to I sub 1 minus I sub 2. Okay? So, simply I sub 1 minus I sub 2. So, we may replace I sub 4 here or equate I sub 4 by I sub 1 minus I sub 2. What about at node 2? This is our node 2. Like Kirchhoff current law at node 2. So, at node 2, we have our current entering is I sub 2 is equal to the current leaving, which is I sub 3, then plus I sub 5. Okay, so what is now the equation for our I sub 5? So I sub 5 will be equal to I sub 2 minus I sub 3. Okay, so just transpose I sub 3. Okay, so we may equate I sub 5, that is equal to I sub 1 minus I sub 2. Or I sub 2, sorry, I sub 2 minus I sub 3. Okay, I sub 2 minus I sub 2. Okay, so that is based on the Kirchhoff current law. What about the Kirchhoff's voltage law? Okay, so we will introduce here a circulatory or circulating current. Okay, so I will introduce IA as a circulating current for loop 1. Then for loop 2, we have our IB. Then for loop 3, we have our I sub C. This is I sub C. Okay, so please take note. Let us take a look at our actual currents. Take a look at the actual currents. So our I1, take a look here. our I1 is going to the right. Then our IA, no? I always assume our circulating current to always be clockwise in direction. So this is clockwise, this is clockwise, this is clockwise. So we have here our I1. Okay, so our I1 or IA, shall we say our IA or I1, I1 simply equal to our IA. Remember that, okay? Because I1 is going to the right and IA is going to the right also. They are just equal, okay? Now, what about IB? Okay? What is IB? Our IB, circulating current IB is going to the right. Our I2 is going to the right also. So, we may say that our I sub 2 that is equal to I sub B. I sub B. Okay? Then what about our I sub C? I sub 3. Our I sub 3 simply equal to I sub C. Okay? So, I sub 3 simply equal to our I sub C. Okay? That is equal to I sub C. Here. Now, we will make use of Kirchhoff's voltage law. Oh, by the way, let us have our I sub 4. By the way, what is our I sub 4? Our I sub 4, it says here, I1 minus I2. But I1 is equal to IA. So, make this as IA. So, it says here, minus I sub 2. So, our I sub 2 is equal to IB. So, therefore, minus I sub B. And then, our I sub 5, that is equal to I sub 2, which is I sub B, minus, okay, I sub 3. I sub 3 is equal to IC. So, minus IC. Okay? Now, let us have by Kirchhoff's voltage law. Kirchhoff's voltage law. Take a look here. Let's say at loop 1, Kirchhoff's voltage law at loop 1. Take a look here. Let us treat, for the meantime, our IA as our circuit tracing. Just like what we have discussed before in Kirchhoff's law. Okay, so the circuit tracing, this is the circuit tracing. Okay, it lives on the positive terminal of E sub 1, so therefore that is positive E sub 1. This is positive, this is negative. It lives. So doon siya lumabas, no? Sa positive E sub 1. So therefore positive E sub 1. Okay, in Kirchhoff's law, if this is the circuit tracing, take a look. That is to the right. The circuit tracing is also to the right. To the right, one direction, one line. One line means subtraction, minus. Okay? So we have here our I sub 1 R 1. Okay, what about here for our R sub 4? R sub 4. Remember that our I sub 4 is going downward. And the tracing is also going downward, like this one. Downward, downward. One direction, one line. Okay? Then we have here our I sub 4. Okay, I will substitute I1 minus I2. So we have here, okay, so that is minus. So we have I1 minus I sub 2, then multiplied by R sub 4. R sub 4. So that is equal to 0. Okay, so we have 1, 2, 3 terms. So we have 1, 2, 3 elements. Okay, so 1, 2, 3. So we have here 1, 2, and 3. Okay, so we have it. Now, let us have this one. E sub 1, positive E sub 1. Let us simplify. Minus I1, R1. Then let us distribute our negative here. So we have here negative I sub 1. Okay. Negative I sub 1. Then also let us distribute R sub 4. Negative I sub 1, R sub 4. Then negative, negative, it will become positive, right? Positive I sub 2, R sub 4. That is equal to 0. Okay. So we have here our E sub 1. So we have here I sub 1 and I sub 1 here. Let us factor out I sub 1. Minus I sub 1. Then we have what now? We have R1 plus R4. R1 plus R sub 4. And then plus, we have our I sub 2 multiplied by R sub 4, that's equal to 0. So, in here, we'll be having our first equation. So, let us have now equation number 1. So, E sub 1 minus, by the way, what is our I sub 1? That is equal to IA here, multiplied by R1 plus R4. Then we have plus, what do we have for I2? I2 is our I sub B, then R4. That is equal to 0. So, we can have here equation number 1. Okay, by Kirchhoff's voltage law at loop 2. Okay, so take a look here at our loop 2. Our loop 2, the second loop here. So, there is no voltage source here. Okay, there is no voltage source. Okay, so let us have our circuit here. This is assumed to be the circuit tracing, let's say. For the meantime, this is not yet the circulating current. This is a circuit tracing because we are using the Kirchhoff's voltage law. This is the circuit tracing. This one. Okay, that is to the right. This is also to the right. To the right, one direction, one line. Okay, so we have one line. So we have here our I sub 2. Okay, this is our I sub 2, R sub 2. Okay, for this voltage drop. What about the voltage drop at R5? So, I5 is going downward. The circuit tracing is also going downward. Downward, downward. So, one direction, one line. Okay? So, minus. So, we have here our I sub 2 minus I sub 3. Okay? Multiplied by R5. Okay? Then, what about for R4? For R4, take note that the circuit tracing is going up. The current in R4 is downward. This is going up. This is going down. Up, down, two direction, two lines. So therefore, it is a plus. Okay? If they are opposite in direction, that is positive. Same direction, that is negative. Okay? Actually, this is still Kirchhoff's law. Okay? So, the circuit tracing, upward. I4, downward. Therefore, it is a plus. Okay? So, but our I4 simply equal to I1 minus I2. I1 minus I2. Then multiplied by R4. So, that is equal to 0. Okay? So, we have 1, 2, 3 terms. So, we have 1, 2, 3 elements. Okay? So, let us simplify further this equation. So, we have negative I sub 2, R sub 2. Let us distribute the negative. This is negative I sub 2. Then, we have here R sub 5, negative, negative, positive. I sub 3, R sub 5. Okay? Then, plus I sub 1, R4. Then, minus I sub 2, R4. That's equal to 0. Okay? So, this is I sub 1 times R sub 4, then negative or minus I sub 2, R sub 4 that is equal to 0. Okay, now let us simplify this circuit. So let us factor out our I2. So let's say this is our negative I sub 2. Take a look here. There is I2 here, I2, and we have also I2 here. So let us just factor out negative I sub 2. So we may say that we have here R sub 2, okay, then plus R sub 4, then plus R sub 5. Okay? So we already have for I sub 2 here and here. So let us put here I1, R4, okay, here. And for R5, plus I3, we have R5. I3, R5. So that is equal to 0. Okay? It's equal to 0. So take note, again, what is our I sub 2? Simply, that is our IB. So negative I sub B multiplied by R sub 2 plus R sub 4 plus R sub 5. Okay? Then we have here plus, what is our I sub 1? IA. Is our IA. IA, R sub 4. Then our I sub 3. What is our I sub 3? That is IC. IC, R5. That's equal to 0. So we have here equation number 2. What about for loop number 3? So by Kirchhoff's voltage law at loop 3. Okay, so this is at loop number 3. Take a look here. We have a loop here. So let us consider first this as our circuit tracing in Kirchhoff's voltage law. Let us forget first our IC here. Let us treat this as our circuit tracing. So it lives on the negative terminal of E sub 2. Therefore, negative E sub 2. Okay? What about here? I sub 3 is going to the right. The circuit tracing is also going to the right. No? To the right, to the right. So, to the right also. So, that is minus. I3, R3. Okay? What about for R5 resistor? For R5 resistor, so the circuit tracing is going up. Okay? If you are to trace this, this is going up. And the current in R5 is going down. This is up, this is down. So two direction, two lines. Plus, what is the current in R5? So we have I2 minus I2. I2 minus I3. And then multiplied by R5. That is equal to 0. Okay? So let us have here negative E2 minus I3, R3. Let us distribute this. So that is plus I sub 2, R sub 5. So this is minus I sub 3, R sub 5. That is equal to 0. Okay? Okay, do you hear me, everybody? Okay, Leo, still listening? Okay, sige, tuloy natin ha. Naintindihan ako ha. Okay, sige. So, tuloy natin. So, we have here our E sub 2, negative E sub 2. Let us factor out I3. So, negative I3, factor out natin. So, we have here our R3 plus R5, then plus I2, R5. Okay, is this correct? Let's double check. Negative E sub 2, then negative I3, then R3, so negative I3, R5, then we have plus I2, R5. Okay, it's correct. So let us simplify. We have here E sub 2 minus. By the way, what is I3 equal to? So of course, that is equal to IC, our circulating current IC. So we have I3 plus R5. Then plus I2 R5. That's equal to 0. Okay. By the way, our I2 simply equal to I sub B. Okay. As we take a look here, actually what we did is we derived. No? We derived the formula or the equation. What can we say about our equation 1, 2, and 3? We can have a conclusion here. We can have a conclusion. What is the conclusion? Okay. Take a look here for equation number 1. Take a look. Our equation number 1. We may say that the Maxwell's mesh method, this is now the mesh current or the loop current, IA. This is IB. Okay. Take a look at our loop 1 here. Again, let us review. Where is our loop 1 here? This is our IA. Okay? Our IA, it lives on the positive terminal of E sub 1. So, doon siya lumabas sa positive terminal ng E sub 1. Okay? So, doon siya lumabas. Kaya ito positive E sub 1. Okay. It simply means that when still, just like in KBL, the Maxwell's mesh method simply means for the voltage, if the circulating current lives on the positive terminal of the voltage source, so meaning it is positive, E. And then what you will do here is already subtract. As we see here, we have to subtract. Okay, we are talking about loop number 1. Minus. Make it minus right away because of what we derived. Minus the loop current for loop 1 multiplied by the loop resistances. This is R1 and R4. What do I mean? Okay, let's go here. So this is our IA. What is our loop resistance? R1 plus R4. Okay? So siya yung loop resistance eh. Siya yung resistance na doon sa loop na yun. Okay? So R1 plus R4 is found on loop 1 only. And then you have to add, okay, the product of the loop resistance of the adjacent loop. Ibig sabihin yung katabing loop. What do we mean by adjacent loop? If this is loop 1, this is loop 2. And the circulating current for loop 2 is our I sub B. So this is I sub B, then multiplied by R sub 4. That's equal to 0. Of course, you have to equate to 0 because that is based on the KBL. What about for loop 2? Take a look here again, guys. For loop 2. For loop 2, we have this equation number 2. We can go directly here. What do I mean? We can go directly here. So this is our negative I sub B. This is negative I sub B multiplied by the loop resistances. What are the loop resistances of this loop? R2 plus R4 plus R5. Okay, so therefore, that's correct. Plus the product of the IA, okay, because R4 is what we call a common resistor. What do I mean by common resistor? R4 is common resistor that is common to both loop 1 and loop 2. Okay? R5 is also a common resistor. It is common with loop 2 and loop 3. Question, is R3 a common resistor? No. Because there is no loop here. Hindi yan common resistor. R2 is common resistor? No, there is no circuit loop here. That is not R1, R2, and R3, they are not common resistor. They are independent resistor. Okay? Again, for a certain loop, okay, make automatically the circulating current to be negative multiplied by the loop resistances plus, okay, plus the product of the adjacent circulating current with the common resistor. Okay? You have to add this. So we have here IA for this case for loop 2. We have here IA plus times R4. For this case, there are two common resistor for loop number 2, which is R4 and R5. So you have to consider this also. IC times R5. That is our equation number 2. Okay? What about for equation number 3? Take a look for equation number 3. Okay, I see it lives on the negative terminal of E sub 2. That's why we have to put here negative E sub 2. Okay? Minus. Automatically. Minus kagad to. Matik na yon ha. Ima-minus mo kagad yung circulating current. Minus the circulating current multiplied by the loop resistance. What is the loop resistance? Okay? Sino yung resistance dun sa loop na yon? Just add R3 plus R5. This. And then plus I sub B times R5. So you have to add the product of the adjacent circulating current to the common resistor, which is R5. Okay, we can't understand this easily until we give a sample problem. Okay? Let us have a sample problem. Okay, actually, we just have the same circuit figure. I mean, just that our E sub 2 here, this is reverse, this is actually negative, this is positive. Okay? What I will do here is I will use directly what I discussed. Okay. Listen carefully. Please listen. This is now the Maxwell's mesh method. Or this is what we call the mesh analysis, introduced by Maxwell. Okay, so for loop number 1, okay, so we have to put first, of course, our given. Okay, so lagay natin yung given. So we have 20 volts here, 20 volts. So we have 2 ohms. Okay, so 2 ohms. So we have here 3 ohms. Dito muna tayo. 3 ohms. Then for R2, may 4 ohms tayo. Then we have 6 ohms. Then we have 5 ohms.
Excuse me, sir. Nawala po video nyo, sir.
Ayan, kita na ba? Kita na?
Still wala pa, sir.
Tanong natin yung iba. Parehas din ba yung iba? Hindi nyo ako kita? Sino nakakakita sa akin sa video? Thumbs up nga. Oh, nakikita naman ako ni
Kita,
ano?
sir, kita.
Yan, kita ako.
Kita, sir.
Kita rin ako ni Ricky. Si Rodney. Si Rodney ba kita rin ako? Ayun, kita. I think sa internet mo yan, Leo.
Maglilib muna ako, sir. Tapos pasok ako ulit.
Rejoin ka ulit. Yes. Okay. Matik yun. Pag kayong mag-isa lang may problema, ibig sabihin sa connection nyo lang. Okay. So, let us continue. Accept na lang natin siya kagad. So, we have here our I sub A as our circulating current for loop 1. It lives on the positive terminal of the 20 volts. Therefore, it is positive 20 volts. Okay, ano sabi natin? What we have said? Automatic, let us make this as negative. This is our IA multiplied by the loop resistance, which is 2 plus 3. So we have 2 plus 3. Okay? So we have 2 plus 3. Then we have plus 3. Okay? Automatic. We have to make this as plus 3. Then multiplied by the adjacent circulating current. We have our I sub B. That is equal to 0. So ganun lang yon. Let us simplify pa. No? Let us simplify. Okay, so 2 plus 3 here. So we have 2 plus 3. So we have here 5. 2 plus 3. So we have 5 here. So let us transpose. So negative, it will become positive. So that will become, shall we say, it is 5IA. Okay, negative, transpose will become positive. Positive will become negative. Negative 3IB. Okay, there's no IC here. I will just put here for our calculator 0 I sub C. Okay, so that is equal to 20. So that is our equation number 1. Okay, that is at loop 1. Okay, at loop 1. What about at loop 2? What about at loop number 2? Okay, that better? Lumiwanag ba? Okay. So, at loop number 2, guys. Take a look here at loop number 2. There is no voltage source. There is no voltage source here. So, just make it as what? Negative I sub B multiplied by the loop resistances. So, sino yung mga loop resistances natin? So, we have 3 plus 4 plus 5. Okay? 3 plus 4 plus 5. 3 plus 4 plus 5. And then, plus this. Make it plus right away. Okay? So, plus na kagad yun. Multiplied by the common resistor, which is 3. Okay? Multiplied by the adjacent, yung katabi niya na circulating current, IA. Okay? 3IA. And then, we have for 5 ohm, again, matik to be 5. Then, we have here plus 5, then multiplied by what? IC. IC. That is equal to 0. Okay? That is for loop number 2. So, let us simplify this. So, this is negative, this is positive 3IA. Then minus. So, how much is this? 3, 4, 5, 6, 7, plus 5. So, that is 12 I sub B. Okay? 3IA minus 12 I sub B. Then we have plus 5 I sub C. That's equal to 0. So, we have equation number 2 now. Okay, nakapasok na ba si Leo? Okay, naririnig na ako ngayon, Leo? Okay, sige. So, let's go now with loop number 3. At loop number 3. Okay, so, our E sub 2, by the way, it is 5 volts. 5 volts. So, this is the negative, this is the positive. our I sub C lives on the positive terminal. So therefore, this is positive 5 volts. Minus the circulating current for loop 3, okay, that should be IC. Okay? Remember that. No? The circulating current for loop 1, that is IA. For loop 2, that is IB. For loop 3, that is IC. Okay? So we have minus IC multiplied by the loop resistances. What are these? So we have what? 6 plus 5. 6 plus 5. Okay? And then plus the adjacent resistor or the common resistor, I mean, that is 5. That is common to loop 2 and 3. So we have here 5. Then multiplied by I sub B. So put here I sub B. Okay? So that is equal to 0. Okay? Equal to 0. Okay, now, let us simplify this. So we have 5I sub B, 5I sub B, minus 6 plus 5, so we have 11I sub C. Okay? That is equal to negative 5. Let us transpose this. Negative 5. So this will be our equation number 2. Number 3, I mean. Okay? So please take note that we don't have IA here, so just put here 0 IA. No? That is for our calculator. Okay? So we can make use again, press your calculator to mode 5-2. Okay? We will not make this as a determinant, as a Kramer's rule, substitution, elimination. No, we will not do that anymore. With the help of Casio 5. Okay? 570 ES plus or 991, no? So, here, okay, we have this calculator. Okay, we can easily solve this problem. Okay, so let us have first our equation number 1. Press now mode 5-2. Then we have here, take a look here. So we have here 5 equals. We have negative 3 equals. We have 0 equals. We have 20 equals. So we have 3 equals. We have here negative 12 equals. So we have 5 equals. We have 0 equals. So we have here, again, 0 equals. So we have 5 equals. We have negative 11 equals. We have negative 5. Negative 5 equals. Then you press equals. Okay, the answer here for our x or automatic, that is our IA. That is our IA, which is 5.08 amperes. Okay? Another equals, that is our Y, which is our I sub B, which is equal to 1.8 amperes. Okay? And then we have for our IC, hey guys, what is our IC here? Another equals 1.27. 1.27. Okay? So that is our answer. So let us have our currents. That is just the circulating current. By the way, again, what is our IA equal to? We said that IA simply equal to our branch current I sub 1, IB is I sub 2, then IC is I sub 3. Again, what is our I sub 4 equal to? Again, I sub 4 is I1 minus I2, which is what? IA minus IB. Let us calculate this. This is our IA 5.08, 5.08, then minus I sub B 1.8. So that is 3.28 amperes. What about our I sub 5, which is I2 or IB minus IC? What is our IB equal to? 1.8. Then minus IC 1.27. The answer is 0.53 amperes. Okay? So this will be our final answer, guys. Okay? Okay? For I1, for I2, for I3, this is for I4, and for our I5. Let us have first. Let's go over with our PowerPoint. Okay, our answer for I1 is 5.08. That is letter. Okay, that's correct. Letter B. For I sub 2, we have 1.8. Okay, that is letter D. Okay. Then for number 3, we have our I3, which is equal to 1.27. Or nearest to 1.28. Okay, letter A. For I4, we have 3.28. Okay, there you are, 3.28. Then for I5, that's for number 5, we have 0.53 or 0.52. That's the answer. Okay? Got it? Nakasunod ba mga kawerpa? Nakakuha? Okay? So we can have another example here. No? Magsa-sample problem pa tayo ulit. Okay? So, we have this circuit. So you may copy our circuit. Please focus here. Para makita nila. Yan, yung circuit na yan. Okay, so let us continue. By the way, just in case we have a latecomer, no, especially to our non-Filipino audience who are watching right now, if there are, no, maybe in the near future, no, maybe we have non-Filipino friends watching our lecture video on our YouTube channel. Good day, everyone. So we are discussing Maxwell's mesh method. Okay, so let us have another example problem. So we have here a three-loop circuit. Dito muna tayo. We have a three-loop circuit here. Okay, so 1, 2, and 3-loop circuit. So we are asked to find here all the branch currents I1, 2, 3, 4, 5, and 6. Then we are also asked to find our VCF, the voltage at C going to F here. Okay, C going to F. What is the voltage here? If we have a voltmeter, okay, you are to measure the voltage here. You are to tap the voltage at C and F. Okay, what will be the voltage? Okay, so let us take a look at our circuit on the whiteboard. So we have here, I just copied the circuit, the given circuit. Okay. The loop current for loop 1 is IA, for loop 2 is IB, for loop number 3, we have I sub C. Okay, so let us have at loop number 1. Okay, so let's take a look here. At loop number 1, we see here our IA, it lives on the positive terminal of 200 volts. So meaning that is positive 200 volts. For 100 volts, it lives on the negative terminal of 100 volts. So doon siya lumalabas, no? It lives on the negative terminal of 100 volts. So meaning it is minus 100. Again, for loop number 1, automatically you will make negative, no? IA multiplied by the loop resistances, which is what? 9 plus 3 plus 14. Okay? 9 plus 3 plus 14. No? Just like what I teach you, I discussed before. Okay? Automatic, for loop 1, our circulating current is minus IA multiplied by the loop resistances, which is 9 plus 3 plus 14 plus, okay, plus the product of the adjacent or the product of the adjacent circulating current and the common resistor. What do we mean? If we have here 3 as the common resistor, that is common to both loop 1 and loop 3. So, automatically make it plus. Okay? Plus. So, we have here 3. Okay? That is plus 3 I sub C multiplied by the adjacent circulating current. What about now for the 14 ohm common resistor that is common to loop 1 and loop 2? So we have here plus 14. That is I sub B. That is equal to 0. Okay, let us simplify. 200 minus 100. So we have here 100. So minus IA multiplied by, so 9, 10, 11, 12. So 12 plus 14, 12. So that is 26. Okay. So we have plus 3 IC plus 14 I sub B. That's equal to 0. Okay, now let us transpose negative IA here will become positive. So that is positive 26 IA. Okay. Negative will become positive. The positive here will become negative if we will transpose. So that is negative I will have first 14, negative 14 IB, and then this is negative 3 IC. So that is equal to 100. That is our equation number 1. Okay? At loop 2. Okay, let's take a look at loop number 2 here. This is our loop number 2. This is our loop number 2. Okay. Our circulating current, I sub B, it lives on the positive terminal of 100 volts. So therefore, it is positive 100. And it lives on the negative terminal of 50 volts. So therefore, minus 50. And then again, automatic, the circulating current for loop 2 is I sub B multiplied by the loop resistances, which is what now? 12 plus 8. Okay. 12 plus 8 plus 14. And then plus, what do we have here? This is a common resistor, 14. Plus 14 IA multiplied by the adjacent current, circulating current, I mean. Then plus, we have here 12 multiplied by I sub C. So that is equal to 0. Okay? Plus 12, 12 I sub C. 12 I sub C. Okay, now, let us simplify this algebraically. So we have here 14 IA, positive 14 IA, 14 IA. Then we have here, okay, let's have first our I sub B here. So 12 plus 8, so that's 20, 8 plus 14, 20 plus 14, 34. Okay, so that is minus 34 I sub B. What about our I sub C? Plus 12 I sub C. Okay? That is equal to 100 minus 50 is 100. Let us is 50, I mean. 100 minus 50 is 50, positive 50. Let us transpose, that will become negative 50. Okay? So this will be our loop equation, I mean, number 2. Okay? Then let us have now our loop 3 equation. At loop number 3, what do we have here? The loop current is IC. That is the circulating current. I sub C here. Okay? This I sub C. So there is no voltage source here. So we can go directly with negative I sub C. Negative I sub C multiplied by, so we have 3 plus 10 plus 12. Okay? So we have 3 plus 10 plus 12. Okay? And then plus, automatic, this will be plus 3 times IA. Then plus, another adjacent common resistor is 12 multiplied by adjacent current. We have I sub B. That is equal to 0. Let us simplify. We have here 3IA plus 12 plus 12 I sub B. Okay. Then minus. So 10, 3 plus 10, so that's 13. So 13 plus 12, 25. So negative 25 I sub C. Okay, so that's 13 plus 12. Okay, negative 25 I sub C is equal to 0. Okay, so that is already our equation number 3. Again, using our calculator, let's use mode 5.2 in our calculator. Let's take a look again with our equation number 1. Okay, press now. Mode 5.2. Again, we have 26 equals negative 14 equals negative 3. Okay? Negative 3 equals then we have 100 equals equation number 2. 14 equals negative 34 equals 12 equals negative 50 equals, then we have 3 equals, 12 equals, we have negative 25 equals, then we have 0 equals, then equals. So our x now, or our IA, is 7.04. Okay, so we have our IA 7.404 amperes. Then another equals, that is our y, which is our I sub b, that is 5.818 amperes. Another equals, that is our z, which is our I sub c. We have 3.681 amperes. Okay? These are just all our circulating current, IA, IB, and IC. So, IA, IB, and IC lang natin yon. So, paki-close up nga. Malabo yung camera na. Okay. By the way, what is our IA equal to? Please take a look here. Take a look again. Okay, I will solve our actual currents. Let us have our actual currents. I will have first our I1. Our I1, take a look at I1 here in our figure. I1, take note in Maxwell's mesh method, if I1 has the same direction as IA, I1 is upward, IA is also upward. So therefore, they are just equal. Okay? Which is equal to 7.404 amperes. What about, guys, our I sub 2? Let's take a look here. Our I sub 2 is going to the right here. That is going to the right. Then our IA is going to the right also. See? To the right, to the right. So, if they have the same direction, meaning just copy it, no, as it is, or that is a positive I sub A. But take note, our I sub 2 is the current flowing through our common resistor. It is a common resistor. The 3 ohm is common to loop 1 and loop 3. If it is a common resistor, okay, kung common resistor yan, you should consider I2 be equal to our IA minus, because our IC is going to the left. Make it as minus. So, I2 is IA minus I sub C. Okay? So, what is the value then? What is our IA? 7.404. Okay? Then minus I sub C, which is 3.681. Again, 7.404 minus IC, 3 3.681 equals, that is 3.723. 723 ampere. What about our I3, guys? I3. Where is our I3? Take a look here. 10 ohm is not a common resistor. It is an independent resistor here. A single resistor. Independent. There's no loop here. Okay? Our I3 is going to the right. And our loop current IC is going to the right. Therefore, they are just equal. Always remember that. If they are just the same direction, therefore, they are just equal. Okay? So, we have I3 that is equal to positive I sub C. They are just equal. Okay? What is our I3 IC? So, that is 3.681. Okay? Amperes. What about our I sub 4? Where is I sub 4? Here. Our I sub 4 is, take a look, that is going to the right. I sub B is also going to the right if you are to trace. Therefore, I sub 4 is simply equal to I sub B. And then, in opposite direction, we have our I sub C here. So, therefore, minus I sub C. So, what is our I sub B? Our I sub B is 5.818 minus I sub C, 3.681 equals. So the answer here is 2.137 amperes. Okay? Then we can go now to I5 and I6. I'll put it in here. Take a look here. What is our I5? This is easy. Our I5 here. Our I5 is going downward. Downward. Okay? That is going downward. Okay, paki-focus mabuti dito. So, this is going downward. I5 is downward. Our I sub B is also, we are to trace I sub B, I5 is downward. Our I sub B is also downward. Downward, downward, the same direction. Okay? So, they are just equal. Okay? So, I sub B, I sub 5 is simply equal to positive I sub B. Okay? So, that is equal to, what is I sub B? I sub B. 5.818 amperes. See? What is our I sub 6? Where is I sub 6? Here. The current flowing through our 14 ohm resistance. Our I6 is going downward. Our IA is also downward. So therefore, that is simply IA. But our IB is going up. So therefore, it is minus I sub B. Therefore, now, our I sub 6 will be equal to IA. Our IA is 7.404 minus I sub B, 5.818. Okay. The answer now will be 1.586 amperes. So these are all the branch currents. Let us have first in the multiple choice. Okay. Oh, unahin natin tong I1. What is our I1? 7.404. Let's see. Okay, what letter? Okay, letter B. What about for I sub 2, guys, here? Our answer here is 3.723. Okay, there you are. The answer is letter C. Okay, what about for I sub 3? Our answer on the board is 3.681. There you are. I sub 3, 3.681. Okay, that's correct. For I sub 4, we have 2.137 here on the board. Okay, yes, that's correct. 2.137 ampere. Okay, then for number 10, we have our I sub 5, 5.818 on the board. Yes, also the same in our PowerPoint. Okay, what about I6, 1.586? There you are. Okay, so kita mga kawerpa, walang daya ha, nakita nyo ha. Okay, walang kadaya-daya. Okay, we have this question. Find VCF. Find VCF. Okay. In getting VCF, okay, I will introduce a voltmeter or a tester, VCF. VCF, okay, VCF, what is our VCF? What is our VCF here? Yan. Okay, put a voltmeter at point C and point F. Then this is our positive terminal and negative terminal. Just like what I have told you before, I teach you before, we just need a single loop to calculate VCF. Okay? We can have this loop, we can have loop, we can also have this loop, we can have this loop, including the voltmeter. Huh? We can also have this loop. Which loop is the easiest? Which loop is the easiest? I think this is the easiest loop. Here. This is the easiest. So, pinakamadaling loop natin. That is the easiest. So, let us make the easiest. Okay? So, for number 11. Okay, so we have here our point F. Our point F, basically, if we are, actually point F, E, and D are just the same. Okay, that is just shorted. Short circuit one. That is basically our F is connected to negative 50 volts, no? The negative terminal of 50 volts. Let us trace here. This is the 50 volt source. Okay? And then the positive terminal is simply connected with the 8 ohm resistor. And then this is our point C. Okay? And then let's take a look here at our current flowing through our 8 ohm resistor. I5. You should not change the current. The current is towards the positive terminal of 50 volts. Okay? So therefore, we will have it here as this, pointing at the positive terminal of 50 volts. This is our I sub 5. Remember that we have a voltmeter here. This is the positive, this is the negative. This is our VCF. Let us have our circuit tracing. This, by Kirchhoff's voltage law, this is not Maxwell's mesh anymore. This is by KVL. Okay, take a look, guys. So it lives, the circuit tracing lives on the positive terminal of VCF. Therefore, that is positive VCF. And then, the circuit tracing lives, no, on the 50 volts, positive 50 volts. So doon siya lumabas. Okay? Kung saan lumabas yung circuit tracing, doon yon. Okay? Okay. So we have here our positive BCF. When the circuit tracing lives on the positive of the voltmeter, that is positive BCF. If it lives on the positive of 50 volts, doon siya lumabas. It lives. Doon lumabas. Okay? At positive 50 volts. So make it plus 50. Okay. Again, in Kirchhoff's voltage law, our circuit tracing is going to the right. Diba? Ito. Going to the right. But our I5 is going to the left. So to the right, to the left, therefore, two direction, two lines. Positive yon. And then, times 8 I sub 5. By the way, what is our I sub 5? Let us substitute now. I5 is 5.818. So that is equal to 0. Our BCF now will be what? So we just have to add this. So ipa-plus lang natin. So 50 plus 8 times 5.818 equals. So my answer here is 96 plus 96.544. That's equal to 0. Let us transpose. BCF now will be, that will become negative, right? 96.544 volts. Well, actually, the negative indication here just simply means that may assume polarity here is wrong. So, that means make this as negative and make this as positive. So that if we have a negative voltage, there will be a reverse deflection, okay, on the opposite direction of your meter. That may be dangerous to your meter. That will damage the pointer of the meter if you are using a analog type of multi-tester or voltmeter. Well, if you are using a digital tester or a voltmeter, it will indicate that it is negative. What you will do is just to reverse the polarity of your meter. Okay, just replace the positive into negative, the negative into positive. Okay? So, basically, our answer is this. You can make this as positive, no? Again, I just put here negative because this is what we calculated. Okay? Ito yung na-compute natin eh. This simply means it is just a wrong assumption because I'm only the one who assumed the polarity of the voltmeter first. This is negative and this is positive, right? If you got a negative meaning, mali lang yung inassume mo. That's what I mean. Okay, the answer for number 11 would be number 12, letter A. Okay? That is the answer. Okay, guys? So, yan po. Sir, how sure are you that that is your answer? How to check your answer if that is right or wrong? How to check? How to check? Okay, just check. Okay? Check. Oh, come on, sir. Okay. I'll show you another single loop. Take a look here, guys. O, tingin ha. Makaka-wear pa, tingin. I will choose the upper one. The upstream circuit here. The upstream tracing here. Okay? I will make use of the 10 ohm resistor here. Let's see if they will just have the same answer. Okay? So, I will use this space here. Okay? I will start with letter F. Our letter F, I will trace this loop. So our letter F is connected to negative of 200 volts. And the 200 is connected to 9 ohm resistor. And the 9 ohm resistor is connected to the 10 ohm resistor. And the 10 ohm resistor is connected to point C. Okay? Let us have our current. The current I sub 1, it lives on the positive of 200 volts, which is flowing in 9 ohm resistor. This is our I sub 1. And our I sub 3 is pointing at our point C. That is pointing in to point C. Okay? This is our point C. So if we are to trace, that will be our I sub 3. You must not change the direction of the current here. Di mo babaguhin yung direction ng kuryente. Ha, mga kawerpa. Okay, guys? Do not change the direction of the current. And then, I will put here the voltmeter. Again, this is positive, this is negative. BCF. This is now the circuit tracing, guys. By Kirchhoff's voltage law, again, take a look here. It lives, the circuit tracing, it lives on the positive BCF. Therefore, it is BCF. Okay? And then, dun siya lumabas sa positive. Wherein, for 200 volts, the circuit tracing lives on the positive 200. What about for 9 ohm? Current flowing is I1. The tracing is to the right. This is also to the right. To the right, to the right, to the right. Okay? That is only one direction. That is 9 I sub 1. What about for the 10 ohm resistor? To the right, to the right, to the right also. Okay? So that is 10 I sub 3. That is equal to 0. 1, 2, 3, 4. 1, 2, 3, 4. Okay, that's complete. Let us now substitute. BCF plus 200 minus 9. What is our I sub 1? I sub 1 is 7. 7.404 minus 10 times I sub 3. I sub 3 is 3.681. 681. That is equal to 0. Okay, will you calculate this in your calculator, guys? Come on. So we have 200 minus 9 times 7.404 minus 10 times 3.681. That is equal to still. So if we are to transpose, that will become negative 96.544 volts. Okay. Again, I just assume that this is the positive and negative. That is why it is negative. But if I will assume that this is already the negative and positive, of course, this will become negative and negative. Just transpose BCF, that will just become positive, right? Did you get that? Okay, nakasunod ba doon? Okay. Sir, I still don't believe with you. You don't believe? Okay, I'll show you another one. Single loop. If you don't believe with my answer here, I'll show you another loop. Okay, here. Let us have, again, a circuit tracing. What about, I will trace the circuit here. I will make it hard for all of us. Okay? Papahirapan natin, ha, mga kawerpa. Pahirapan natin katawan lupa natin. Okay. Ito. This complete loop. Itong kompletong loop na ito. We will consider this loop. Okay. Pahirapan natin, ha, mga kawerpa. Okay. Warren Buffett said, Warren Buffett is one of the billionaire of this world. Warren Buffett. Warren Buffett or Buffett, Warren Buffett, he said that do what is hard. Okay, let's make it hard. Okay, let's follow Warren Buffett. So, let us have point F. He said that if you want to become successful in life, do what is hard. That is what we are doing right now. Okay. So, point F. So, we have here negative of 200 volts. Then, this is the positive. Then, we have our 9 ohm resistor. Then, we have here connected to the 3 ohm and the 12 ohm. 3 ohm, 12 ohm. This is 3 ohm. This is 12 ohm. Okay? And then, the 12 ohm is connected to C. This is point C. Remember, this is our point F. We just need that. Okay. This is our VCF. Okay. I will assume that this is the negative and this is the positive terminal. Okay? And then, let us have the current flow. I1, we have on this direction. Okay? It leaves on the positive of 200 volts. We have that direction. Must not be affected. The direction. Okay? And then, we have our I4 is pointing in or pointing towards point C. And then, I4 is the same direction as I2. Okay. Then, let's make use of the Kirchhoff's voltage law. This is our circuit tracing. Okay? By the Kirchhoff's voltage law, so what do we have here? Again, it lives on the negative of BCF. That's why BCF, negative BCF yon. Okay? That's negative BCF. Then it lives, the circuit tracing lives on the positive of 200 volts. So therefore, it is positive 200. Remember that our circuit tracing is going to the right. All of these are going to the right. Okay? To the right. This is also to the right, to the right, to the right. Only one direction. Therefore, that should be minus. Okay? Minus 9 I sub 1. Minus 3 I sub 2. Minus 12 I sub 4. That is equal to 0. Negative BCF plus 200 minus 9. Let us substitute now. I sub 1. 7.404. Okay. Then minus 3. 3 times I sub 2, which is 3.723, minus 12 times I sub 4, which is 2.137, that is equal to 0. Then, what is our BCF equal to? Let's see if they will have the same answer as before. Okay, let us input 200 minus 9 times 7.404, then minus 3 times 3.723, then we have minus 12 times 2.137 equals Well, the answer here is 96.551. You see, sir, you are wrong. Really? Sir, because the answer here, show here, is 96.544. Your answer is 96.551. See? Oh my goodness. This is just a little difference because we are dealing with decimal places. You see a little difference of 44. This is 44. This is 51. Yun pa ang nakita mo. Hindi mo nakita yung parehas na 96.5. Okay? That's ridiculous. Okay? I still don't believe, sir. Ah, really? Okay, I'll show you another one. This will be the last. Look. Okay. I will make it hard again for you. Okay. For all of us. I will make the circuit tracing here at the middle. I will use the middle circuit here. The middle tracing here. This one. I will make it hard. Okay. Okay, guys, I will show this to you. Let us have a circuit tracing here. I'll show you the last circuit tracing here. I'll start with point F or point E. Just the same. They're just the same. Our point F is connected to negative of 100 volts. This is 100 volts. It's connected to a 14 ohm resistor. And then the 14 ohm is connected to the 12 ohm resistor. And the 12 ohm is connected to point C here. Okay, then I will have here the voltmeter. I will make this as negative and positive, BCF. And then let us have the current flow. What is the current flowing in the 14 ohm resistor? That is our current I6. The current I6 is towards the positive of 100 volts. This is 100 volts. That is towards, that is pointing at 100 volts, positive 100 volts terminal. Okay? So this is 14. Okay? 14 ohm resistor. So this is our I sub 6 pointing at positive terminal of 100 volts. So this is our I sub 6. I sub 6. Then our 12 ohm resistor, there is a current flowing. We have I sub 4 that is pointing at point C. Okay? Going at point C. So make this as I sub 4. Then let us have the circuit tracing. This is the circuit tracing, guys. That one. This is by Kirchhoff's voltage law. What is the Kirchhoff's voltage law here? This is negative BCF. Again, this is negative BCF. So this is plus 100 volts. Okay? Again, for 14 ohm resistor, the circuit tracing is going to the right. But I6 is going to the left. To the right, to the left, two direction, two line. So we have here 14 I sub C, I sub 6. And then, the circuit tracing is going to the right, I4 is going to the right. To the right, to the right, to the right. Okay? So we have here 12 I sub 4. So that is equal to 0. Okay, negative VCF, let us just substitute. So we have here 100 plus 14 times I6. Ano ba yung I6 natin? Nakuha natin. That is 1.586 minus 12 times I sub 4. I4 is 2.137. 2.137 is equal to 0. Okay, let us calculate now. 100 plus 14 times 1.586 minus 12 times 2.137 minus 12 times 2.137. So that is equals 96.56. Okay? So, our BCF equal to 96.56. See? You see, sir? You are wrong. Really? I am still wrong here. I already show you 5 circuit tracing. No? 4 na yung pinakita ko sa iyo. We have here 1 loop. That is the first. Then the second one here. Then the third one here. And the fourth one. They are all have the same value. Okay? Of course, there is just a little difference because we are dealing with decimal places. We are not dealing with fraction here. Okay? So, you see, there your answer before is 0.544. But you have 0.6. Etsa by galiwa. Okay? My goodness. Pambihira ka. Hindi mo nakita yung 96.5? What you will do is, you go to the building, you open the window, and you jump. Okay? Because you don't believe. Okay? So, that's it for today, guys, no? Okay? About the Maxwell's mesh method. That is just the part 1, no? Okay? But wait, there's more. Oops. Meron pa pala. Okay. Sige, i-drawing ko na lang yung sa board, yung sa 13, kasi wala tayong drawing dyan. PowerPoint. Okay? I will have for number 13. Last problem. Okay, this is for number 13. We are asked to find V. There is a voltmeter here. Find V in the circuit shown. Okay? This is our circuit. Okay? Let's take a look here, guys. We have a 3-loop circuit, but for this case, we have an independent current source of 10 ampere. Okay? One may see it that you will make use of the mesh analysis or the Maxwell's mesh method. But it's not. I will show you that this is just a Kirchhoff's voltage law. You don't have to introduce here your mesh current or loop current here. For a 3-loop circuit, then you'll come up with 3 equations, 3 unknowns. No need for that. The only question here is to find V. We will just solve this by Kirchhoff's voltage law. Again, what is Kirchhoff's voltage law? The summation of any loop is simply equal to 0. Okay? So that is only equal to 0. The summation of voltages around any loop is equal to 0. I will just consider the outer loop. What do I mean? The outer loop. Okay. I will just consider this loop. Let us forget this 10 ampere. I will disconnect this. Pack. I will disconnect this R sub 2. Pack. I will disconnect this. Pack. So I will just have a rectangle here. I will just consider that as a single loop. This rectangle. So I will introduce the circuit tracing on this direction, always. That is always clockwise in direction. Okay? That is always clockwise in direction. Clockwise. Okay? Parating clockwise yan, ha, mga kawerpa. Always clockwise. Let us forget the inner network here, the inner circuit. Just consider the outer loop. Because the only question is V. Find V. Okay? What do we have here? As we see here, this V is considered to be a voltmeter that has a positive, negative terminal here and has a positive terminal here. Well, actually, guys, this 40 volt source, this is, we can consider that this is also the measured value in the voltmeter. Just like this one. This positive is this positive terminal, and the negative is negative terminal. They're just the same. What about that? Let us have now the Kirchhoff's voltage law. This is now the circuit tracing. The circuit tracing lives on the positive terminal of 40 volts. Therefore, that is positive 40 volts. And the circuit tracing lives on the negative terminal of the voltmeter. As you see, dun siya lumalabas. It lives on the negative terminal. Dun siya lumabas. That is why negative B. What about here? This is, the circuit tracing is downward. The current, 16 ampere, is also downward. Downward, downward. One direction, one line. 3 times 16. What about here? This is the 2 ohm resistor that is going to the left. The circuit tracing is going to the left. The 4 ampere current is also going to the left. To the left, to the left. One direction, one line. So we have here 4 times 2. So that is equal to 0. The only unknown here is v. We can easily dissolve v. Or we can transpose. This is negative b, make it a positive b. So that this will just be 40 minus 3 times 16 minus 4 times 2. What is the answer for the voltage? V. Okay, so we have 40 minus 3 times 16 minus 4 times 2 equals, the answer would be negative 16 volts. Okay? I will consider the negativity of voltmeter V because the author already assumed, he is the one assume that this is the negative and this is the positive terminal of the voltmeter. Okay? Just remain the negative sign. Therefore, in our choices, what letter is our answer? Letter C. Okay? Did you get that? Did you get that, guys? Well, that is the end of our Maxwell's mesh method. This is just part 1. We still have part 2 of Maxwell's mesh, and that will be on, kailan yun? Friday. That will be on Friday. What is that date? Okay, that is September 11. That is the 9/11. It's a memorable day. Okay, not only in New York, in US, but also in the world. Okay, that is the day when the Twin Tower falls. What year was that? Okay, on September 11, we'll see each other again. I hope so. Okay, but to our Filipino audience, no, I'm inviting you tomorrow. We have a free webinar. Okay, so that's it for today. Anyway, baka may mga tanong. Are there any question to our audience? May I see them? Patingin nga sila lahat dyan. Oh, ano nangyari? Na-disconnect na yung iba? Na-disconnect na? Dalawa na lang ba sila? Kanina, less than 10 pa yan. Okay. Sige. Sige. Okay, Leo. Are there any question, Leo? Or comment? You have any comment on what we are doing? Leo?
Sir, actually, I understand the topic, but
Okay.
I need more review to make
Of
it
course.
more.
You need more practice, of course. No? Even
Yeah.
me, up to now, I'm doing some practice before I teach you.
Yeah.
It should be. It should be. Learning is a never-ending process. No? Always
Yeah.
remember that. Okay? Leo?
Okay.
Thank you. What
Yes.
about the other guy? Parang, first time lang ba niya? Anong pangalan niya? What's his name? Rodney? Okay, Rodney. Okay,
Yes.
do you have any question or comment? Or
Wala po, sir. Ganda po, sir. Naintindihan ko po yung ano, sir.
what is your course, Rodney?
BSE po.
Graduate ka na ba?
Ano po, this January po.
What school?
BPSU po, Bataan.
BPSU. Okay, Rodney,
Main.
I'm inviting you ha sa ating mga ginagawang ito, Restudy EE, pre-webinar.
Opo.
Okay? So,
Opo.
what is your comment, Rodney, on is this your first time to attend to our pre-webinar or Restudy
Nung
EE?
sumasali po ako sa mga pre-webinar po.
Okay. What in the Restudy EE? Is this your first time?
Nung nakaraan po, dito po, naputol po kasi yung signal. Tapos di na ako nakabalik.
Okay. Okay. Okay, thank you Rodney. No, wag muna kayong kakalas ni Leo ha.
Sige
Usap
po,
muna
sige
tayo
po.
sandali.
Sige
Okay,
po.
magpapaalam lang ako sa ating audience. Okay,
Sige
to
po.
our people of this world, okay? To our students, okay? To all our viewers, thank you very much for watching. So I'm inviting everyone whoever you are, whatever your races may be, if you are an American, European, or African, you're an Asian, no problem. We are doing this. No, this is our little share to the world, supplying a little knowledge about electrical engineering. No? So this is a very noble profession. No? What I believe, because there are doctors and nurses who are busy in the hospital, but many people don't know that for them to be able to work in a hospital, there should be somebody to maintain the supply of power of all this medical equipment. Okay? That is a very important role of an electrical practitioners, of our engineers, our technicians. It's really very a noble profession. Okay? Our profession is one of the essential profession in this world. So I hope that you always keep on watching our videos on YouTube, on my YouTube channel. Okay, by the way, I have to show this first. Pakita muna natin sa kanila to. Okay? Everybody, we want to invite you. This is an English version. No? I just talk a little of our language in Filipino. Okay? But don't worry, I can assure you 100% you will understand the lecture if you are listening carefully. So, that is just a little request. No? You will not understand this if you don't listen. Okay, so please listen carefully. Okay, so we have the study electrical engineering. Okay, we are just on topic number 2. Okay, so hindi pa rin tapos yan. We are not yet finished. No? This is a very long subject, the direct current circuit. So I'm thinking last night, no? I think this will take not only 2 years, it can be 3 or 4. If I will really make it as a detail, just like a book. So let's say we are an book on air, right? We are an electrical engineering book on YouTube. Okay, we are just like that, so that we can help our students all over the globe. Filipino schedule, MWF, 9 to 12 noon. Okay? So our Zoom ID will be posted at least 1 day before in our Facebook account. So that is Marinai's Powerhouse Facebook account. For Master Electrician, we have a Master Electrician Fundamental course that is every Sunday, 9 to 12:30 p.m. Philippine time. So the Zoom ID will be posted in our Facebook again, at least 1 day before. Okay? With free e-certificate at the end of the course. No? So, and you will have a chance, to our Filipino audience, you will have a chance to be a scholar in our regular review for REE and RNE for April 2021 board examination. Okay, this is a first come, first serve basis. I just hope that you will invite. It's quite sad because there are 2 participants only. So, in our webinar, we already had more than 100 or little less than 200 participants. So I just hope that we can also have that in our study of electrical engineering. No? Well, anyway, this is just a recording, no? So that this will be a content in our YouTube channel. No? So you may watch it over and over again so that you can master the topic. Okay? This is a very useful topic, no? That you will be encountering in your upcoming endeavors, especially in the licensure examinations. Okay, this will be very helpful. We are inviting you, so please subscribe, like, and share my YouTube channel. So this is a Reggie Marina YouTube channel. So I hope, no, you subscribe first, no, you make a comment, you like, and please share to your loved ones, no? Not only to your loved ones, no? To your friends, even to your enemies. So you can share this, no? This is a very helpful topic for everyone. So with this, guys, I should say thank you very much, no? God bless you all. Stay safe. Thank you.